Hello, Summer. To answer both your emails, you have got to know how to rewrite variables if they're in the denominator or if they're under the radical. These two rules are very, very necessary, and they'll serve you well in this chapter, chapter 11, and chapter 13. Well, 12's in there too, but these are used heavy in those particular chapters. Now, I had some examples here how to rewrite. I'm going to do a few of these, but it's imperative that you're able to write these problems in the form of a constant times x raised to an exponent. So in this one, only the variable moves, so that would be 1/2 x, and if I move it to the numerator, it becomes -3. In this one, it's the variable I'm worried about, but the number, I leave it alone. That's my c, that's my constant. So that would be x to the 2/3. In number 6, that would be a -9, x to the -7. And number 8, that would be a -12, x to the 6/7. Whatever the order is, right here in the elbow of the radical, that's always in the denominator. So whatever exponent you see with the x, that's always in the numerator. Now if I had this problem, I didn't mean to do that. I meant to write this. 4 square root of x, that's the exact same thing as that, because it's understood to be a 1 here, and when you heard me read this, I said square root. The 2 is understood. So now to get to your questions, this is the underlying issue. But to get to your questions, if you'll notice on this, I rewrote it. You have to rewrite because, again, you have to get it in the form of c times x raised to the nth power. No variables or radicals allowed in the denominator anywhere. So that became 2x to the -3. This one in the denominator would be x to the 2/3, but when you take it up, it becomes a -2/3 plus 7. Now, my rule is this. It's called my power rule, and this is why I've been writing this down the whole time. To get your derivative quickly, you multiply exponent times coefficient, that's that piece, decrease power by 1, so we're subtracting 1. So if I get my derivative on this one, let me put my f prime so I'm showing you what I'm getting. -3 times 2 is a -6x decrease power, so -3 minus 1 is a -4. -2/3 times -6 is a positive, and if you're not good at fractions, throw them in the calculator, but make sure you've got parentheses around your fraction. So that would be, should give me a +4x. Now in your calculator, do -2/3 minus 1 and go frac it under the math menu, and if I do that, you should have that -5/3. Technically this is x to the 0. 0 times 7 is 0, so if you have a constant, it becomes 0. So that's why on this problem that happened. Now the other problem, let me get to it. You have to go, now average rate of change, that is slope. Go get the points that go with a t-value of 1 and a t-value of 4. Plug those in. Let me see, if I plug a 1 in, that looks like that should give me a 6. If I plug 4 in, oh boy, let me see, that'd be 32 times 6. 192, I believe. But go find your slope. That's what average rate of change is. But now this means instantaneous rate of change. So I've got to go get my n prime. 5/2 times 6, that would give me 15. Try it via calculator, but put 6 times 5/2 and then go ask it to frac. But now, once I do exponent times coefficient, decrease power by 1. So 5/2 minus 1, that will give you your 3/2. Again, try it via calculator. And also remember to frac that thing. Alright, I hope that helps. Just let me know. Thank you.